All right, I figured that y'all would be really sad if that you didn't get to hear my voice. So here I'm going to go through a couple of notes for you for 6.3. First of all, I'm going to share this document with you, but the first thing, it's got the answers to what you did in class on Friday. It has the answers and a link here for the study guide that was weekend homework. And then here's the meat of the lesson, 6.3. You can follow along in your book if you want to. It is, yikes, page 375. So far, when we want to show that two shapes are similar, we have to know that all of the angles that correspond are congruent, all the sides that correspond are proportional. Remember, that's called the scale factor. We should probably add that in. But today, what they're adding in is some shortcuts, kind of like when we did congruent triangles, how they started adding in those shortcuts like side, angle, all those things. The first one is called AA. So not the support group, but for triangles, AA says that two triangles can be similar. If two angles of one triangle are congruent to two angles of another, the two triangles are similar. The reason this works is because third angles theorem, because if the two triangles themselves have two sets of congruent angles, the third angle has to be congruent. And the definition of similar polygons, all the angles are congruent. So there's your new reason, AA. Moving on. First example, determine whether the triangles are similar. If they are, write a similarity statement and explain. I've already worked it out, but I'm going to walk you through what I did so that you can just get it real quick. In the pink, purplish color there, the smaller triangle, it has one angle that's 26, one that's 90. So you can figure out the other one is 64, angle E. The larger triangle on the right, you have an angle that's 90. You have an angle that's 64. So the smaller angle has to be 26. Therefore, they have two sets of congruent angles, which means that the two triangles are similar. So one example of a similarity statement is what I've written here in blue, triangle CDE similar to triangle KGH. Example 2, show that the two triangles are similar. Part A, you've got these overlapping triangles in the black print from the book. So what I did, the blue and green, I took the two apart and drew them separately. So the blue one is that top smaller triangle. The green is the larger triangle altogether. If you notice, they both have an angle that's 52, so those are congruent. So angle B is congruent to angle C. Also, they share angle A. Because they share angle A, it's obviously congruent to itself by reflexive property. So, two sets of congruent angles, they are similar triangles. Hold that thought. You got the brain to my belly. All right. The next part B there, if it wants to know if triangle SVR and UVT are similar. First off, it makes an X in the middle, so that's vertical angles, what I have marked in red. And then the pinkish purple, you have parallel lines and a transversal. That means the angle T and angle R are alternate interior angles, which have to be congruent. So two sets of congruent angles, those two triangles are similar by the reason AA. All right, that is AA, angle similarity. The other part of this lesson is called indirect measurement. We did this before with congruent triangles, but now we're going to do it with similar. So the only difference here is that we're going to be making proportions instead of just straightforward equations. A flagpole casts a shadow that's 50 feet long at the same time. I'm so sorry, my boys are loud. 1 second. Okay, let's try again. A flagpole casts a shadow that's 50 feet long. Same time, a woman standing nearby, 5 feet 4, casts a shadow 40 inches. How tall is the flagpole? So the woman, they're giving us feet and inches in a combination. The flagpole, they're giving us feet. That's okay, as long as you keep the lady's measurements together and the flagpole's measurements together, because it's kind of like when you have the two separate triangles. I told you to have one triangle across the top and one across the bottom. So I drew out my triangles. The blue is for the lady. She's 64 inches because I changed her height to inches, so that everything about the lady's now going to be in inches. So she's 64 inches tall, and her shadow is 40 inches long. That's the blue. The green is for the flagpole. It told us that its shadow is 50 feet long, so I labeled that on the bottom. And I'm trying to figure out how tall it is. That's my red X. So if I do my proportions, the height of the lady is going to be proportional to the height of the flagpole. So I have 64 over X, because those are the corresponding sides. The shadow of the lady is going to be proportional to the shadow of the flagpole, because those are proportional sides. So I have 40 over 50. By cross multiplying, I get that X equals 80. And that would be option C. All right. Those are all the examples in the section. I would recommend here at the bottom of this document that I'm going to share with you, it tells you how to get to some extra practice where you can listen to someone else teach it without crazy children in the background. And you have some try the exercises that you can do as well. I hope you'll have a great day. Stay safe.